talking about applying Sigmafine and thermodynamics, the thermodynamics extension for energy balances and for performance monitoring.
All right, thank you.
Yes, thank you, Carlos. Yes, again, my name is Cody Drake. I am a project engineer and Sigmafine product specialist here at PIMSoft, here in the Houston office. This presentation was put together by some of my colleagues in some of our Italy offices, so it's my pleasure to get to present it to you all today. And as Carlos says, I think I'm the last thing standing between us and what looks like it's going to be a pretty good spread for lunch. So we'll go ahead and get started. All right, some of the topics we're going to be talking about in this presentation. We're going to talk about how Sigmafine can work in the energy domain and how it can be applied to utility networks, LNG, and the power industries. We'll also be talking about equipment, key performance indicator evaluations and performance monitoring, and then we'll briefly touch on the iOS 50001 compliance for energy efficiency and how Sigmafine can serve you in meeting those standards. So if energy monitoring and management wasn't considered a priority in running a plant 20 years ago, it certainly is today. It's certainly on everybody's mind. Companies all around the world need a trustable method to satisfy the need for verifiable and trustable data, energy data specifically for trading partners. They need to operate within environmental permits and controls, and we all want to maximize profits by focusing on efficiency and energy savings. Sigmafine can be applied to numerous industries and processes to address these challenges, including LNG production, revaporization, steam power, and utility networks. To get appropriate and applicable information in the energy context, Sigmafine provides a set of trustable data based on validated and reconciled quantities that can apply to energy content on a few different levels. One being energy accounting, especially for energy balances. This can be applied to the fuel, gas, steam, and electricity networks. And then on another level, Sigmafine can be applied to performance monitoring. So we can take our post-model based data reconciliation values, and then take those values and calculate KPIs or calculated values such as work and efficiency. And they can be reviewed within the Sigmafine framework, which provide reliable KPIs because they are based on reconciled and validated data. Sigmafine works by receiving data from your plants, from your data historian, from LIMS, manual entries, and then it applies an analysis to a model, which is a representation of your refinery and its assets. A Sigmafine balance is typically or an energy balance can be applied to the collection of these assets. A Sigmafine balance typically applies a linear balance, calculating reconciled values based on raw measurements and tolerances, which are the confidences that you have in your meters and your measurements, and then provides reconciled values. Now we have an energy balance that does the same, but with an extra degree of data. Sigmafine is able to perform a simultaneous balance of both mass and energy. Because of this extra degree of data, it's solved through an iterative solution. After this, we can use a few different Sigmafine extensions to calculate valuable and validated KPIs. These extensions being the steam tables, the thermodynamic extension, and LNG calculations. All of these tools make Sigmafine a system where you can merge the accounting targets and engineering targets all in one scenario according to the level of detail you're interested in, whether that be a boundary model or specifically around singular units or an entire refinery. Here's a basic example of a Sigmafine model applied to a fuel gas network. Here we have each asset represented by standard Sigmafine templates represented in a process book model display. We have a model that represents your network starting from your sources. That could be natural gas from outside your plant or fuel gas that your plant produces, going to nodes where your sources can mix together, and finally moving towards your destinations or your shipment points, exiting your plant or exiting your refinery and going towards their destination or towards consumers where the fuel can be consumed. Here's where Sigmafine would normally apply or be used for a mass balance. Then we combine that reconciled data with analyzer information that gives us the component breakdown of our flows, and we're able to calculate values such as a lower heater heating value. So starting from this, we can have our Sigmafine calculations help us calculate energy content within your networks. Another example here we have of a Sigmafine application to energy in a steam network. We have a very small detail of a larger model here. This model contains the complete steam network of a big plant. On this model, Sigmafine applies an energy and mass coupled or concurrent balance. So we have to include both informations about measured mass and measured specific energy. So since we are talking about steam, to calculate the enthalpy of steam, we have to apply steam tables provided by Sigmafine in the background. And we're also able to see on the right-hand side of this slide details of a valve calculation. So starting from the opening of a valve indicated either manually or from a pi tag maybe, we can estimate the flow rate that passes through our system. Now the advantages of having a coupled or simultaneous mass and energy balance is we have a higher degree of redundancy. The more data we have to compare against one another, the higher our degree of redundancy and the more confident we can be in the system's reconciliation, which provides that rigorous calculation. Some of the challenges associated with that, obviously with more data, more calculations, that iterative solution, we have a slightly higher degree of model complexity, right? And also an understanding that our balance is being solved iteratively instead of linearly. In LNG, the application of Sigmafine is primarily concerned towards data validation to verify the cost of transfers and other measurements, and to determine the state of your terminal. So in this case, we have a model that represents an LNG treatment and purification. We've got a feed with two pipelines that enter and are mixed or coupled together. We have information about mass content and also its composition through these analyzer elements, which are critical in the LNG industry in determining the energy content of your production. So the base of the Sigmafine analysis is the mass and component balance. And on top of this, we can also run the energy balance so that all of our data and all of our reconciliations are consistent with each other. To support the energy balance calculation in LNG, Sigmafine can provide a set of calculations through the LNG extension that reads the composition of flows and estimates the mass calorific value. Of course, if the composition is reconciled from the base mass and component balance, we can be more confident in the mass calorific value that is calculated. We can calculate other important values such as tank density through the LNG extension, which is also based on reconciled data. Here we have another example of Sigmafine applied to energy in power generation. In the power industry, some major needs are the transparency and trustability of data of the entire business because of the industry's direct relation with the public. Another need in the power generation industry they have to manage huge amounts of data that they deal with, along with inherently inaccurate measurements. So Sigmafine can validate the unit production efficiencies and also automatically transfer this data to a business system and support compliance. So an hourly production balance can be applied to a model to have a near real-time target assessment. And finally, you can also monitor production, including emission assessments and emission parameters to support environmental strategies and regulations. This near real-time assessment can allow users to assess unexpected movements or values, to plan for corrective action, and then to estimate losses and monitor performance. Let's talk about the thermodynamics extension and calculating key performance indicators. So conventionally, operators and process engineers monitor the status of the plant by looking at raw data and trends and charts and displays. For process information that can't be directly seen in measured data, such as the amount of heat exchanged in reboilers or the efficiency of heat exchangers, the thermodynamic extension can use equations of state to provide accurate estimations. Now, the extension works by considering the composition of flows. Starting from this, it performs the equilibrium calculations based on equations of state. Then the extension estimates the properties of that flow. So here we have an example where the extension is being used to calculate the enthalpy of a mixture. It starts with the physical properties of that stream, the temperature, the pressure, and then also looks at the composition of that stream. And then it's able to calculate further thermodynamic properties of the fluid. Here we go, going from composition to the physical properties to the calculated value of enthalpy. Here's another example of a model where the thermodynamic extension is applied. This is a multi-stage compressor. You can see in the display maybe, if it's big enough up there, we have 5 compressor stages where each compressor has different properties. The process engineer would typically be familiar with the pressures and temperatures that these compressors are operating under, and is also interested in the work and efficiency of these compressors. So by monitoring and having the results of these calculations, the engineer can take corrective action if something's not working. The scope of using the thermodynamic extension also includes monitoring calculated KPIs. The problem is if you don't have Sigmafine working for you and producing reconciled and validated values, you may have inaccurate KPI values. I think this is something that Massimo probably touched on a little bit earlier. Here on the left side, we have an example of a specific consumption of steam in a reboiler. I think it was a purification column. We can see that when you calculate this index based on raw data, you have a very different value than when you calculate it based on reconciled and validated data. And this difference was actually yielding €2,000 a day hidden operating costs because they were operating on the assumption that the raw data was correct. But after correcting for looking at redundant data and using Sigmafine to produce reconciled results, they were then able to operate under a more accurate KPI. We have another example here, and I know Massimo showed this earlier, of how data reconciliation can improve the accuracy of a key performance indicator, specifically the efficiency of this industrial furnace. On the left side, we have that raw data that shows a really poor correlation between the efficiency of the furnace and the oxygen content in that flue gas. While on the contrary, after the reconciliation, we're able to see a good correlation based on the oxygen content and the efficiency. The engineer can then better plan for crude batches. So all of these thermodynamic calculations are also available via the Sigmafine app. The main advantage of this is you can use the app to empower AF analytics to monitor the performance in almost near real time and write the results directly back to Pi in a really efficient manner. So this last section, we're going to be talking about the ISO 50001. Energy management is more important today than ever. We already saw or talked about at the beginning of this presentation how energy price changes and environmental concerns are changing company challenges. So we come to the ISO 50001. This standard is an internationally recognized system that controls energy management systems and sets goals for increased energy efficiency, optimizing resources, and minimizing environmental influences. This standard is consisted of 4 different phrases that we see up here on the slide: act, plan, do, and check. And we would argue that check is one of the most important pieces of this flow diagram. If we're operating under poor assumptions, if we're operating because of poor data or poor measurements, our actions are not going to help us achieve our goals. So before taking action, we want to be sure that the numbers we're looking at, the data we're looking at, have high utility and are reliable. This is an example here on the right of a model that contains some furnaces. We have the feed to the furnaces and the air and all the assets, such as the superheater. So what's done here is an analysis of the integrated mass and energy balance. That nonlinear solution is applied, and the calculation for thermodynamics are implemented so we have trustable data that's validated by the analysis. An accurate estimation of the flow properties is also achieved through Sigmafine and the thermodynamic extension. And then finally, we have these key performance indicators that are calculated and made more consistent by the Sigmafine analysis's reconciled data. So a way to improve the real-time operation is to monitor all of these results from the Sigmafine analysis in a graphical way. This is an example up here of a Power BI dashboard that can be used for ISO 50001 to support the energy management decision making. Power BI is a really powerful tool used for visualizing data and specifically really useful for this. So the advantage for this is the data can be calculated automatically in the back end. We just talked about how, Roberto talked about how we can automate our Sigmafine analyses, so our production engineers may not even need to touch the system, enter things manually. They're able to see this dashboard and take action based on these reconciled calculated values. So to conclude, Sigmafine energy balances can be used to validate the quality of raw data, whether they come from PI or LIMS or manual entries. The validated and reconciled values that are produced from Sigmafine can then be further leveraged to provide accurate KPIs, processing properties, and then provide better insight and actionable data for the process engineers. By way of Sigmafine, companies can support their effort to subscribe to energy saving practices and efficiency improvements that are laid out in the ISO 50001. I'm a part of our delivery service team, but also our technical support team. So we've got some contact information up here. First off, if you aren't already on the Sigmafine support portal, we have documentation for all of these extensions available here on our support portal. If you need to register, you can go ahead and register on the website today or at another day, and we'll get you hooked up there. We also have, I don't know if I have contact information, but Sigmafine support at pimsoftinc.com. We're also always available to help answer questions or any concerns that you guys have with your model as you're working with it, or if you're interested in maybe new implementations as well. So, thank you very much.